Alrighty, ladies and gentlemen, welcome to you. Today I'm going to teach you about the nomenclature flowchart for chemistry. Okay, and so we are going to create a huge document here. Okay, and so when I think about a flowchart, we're going to create something that looks like this. Okay, when I think about a flowchart, I think about Dorothy, right? I think about the Wizard of Oz. Odd, but hear me out. So flowcharts are something you follow along to get to the outcome you want, right? Follow the yellow brick road, follow the yellow brick road, get to the wizard kind of thing, right? So there's a nomenclature flowchart that we follow in chemistry that helps us to be able to name and write chemical compounds. And so I'm going to give you the flowchart. You're going to write this in your packet on the page that says nomenclature flowchart. I don't know why it has that black weird thing at the top that came from the copier. Please bear with that. It is what it is. All right, so every single time you go to give a compound a name, the first question we are inevitably always going to ask ourselves is this question, and it is this. Does the compound, and yes, it has to be a compound, meaning it's made up of two or more types of elements, right? Does the compound contain a metal? So the first thing I need to do is I need to remind you of our definition of what a metal is. So I hope you all can see this, right? Periodic table. So we said that if we take a periodic table and we start in the corner up by boron, and we go down and over, down and over, down and over, down and over, down. To the left of that, right, over here are our metals. These are positively charged cations when forming compounds. Now, over here on the other hand, symbolized in green, we have our nonmetals, okay? And so these things over here are negatively charged anions. So the first thing we've got to ask ourselves is, do we have a substance that's located on the left side of the periodic table? And if we do, it's a metal. And so, okay, so the answer to this first question is pretty simple, right? It's either yes or no. Now, if the substance is yes, we're going to give it a name. We're going to call that an ionic compound. And likewise, if the answer is no, it's going to get a different name called a covalent compound. Okay? There's one exception to that when we do acids, which are just that. They're acids. But for now, we're going to go over here, okay? Ionic. And so what you're going to ask yourself as a second question, if the answer was yes, is you're going to look at the metal and you're going to ask yourself this question. Is the metal a transition metal? So that requires me to go over and remind you where the transition metals are located. And so the transition metals on our metal chart are block that are located right here in the center. So scandium, titanium, vanadium, okay, all the way down here to zinc, okay? And so if you are in this center rectangle, you're a transition metal, okay? So that's the next thing we ask ourselves. And again, the answer can either be yes or no. Now, I'm not going to do too much teaching right now of how do you do each and every one of these. I just want to kind of get the flow chart down on a piece of paper, okay? I will teach you more about where do we find transition metals, how do we know what they are, all of that. But, all right, so if the answer is yes for is the metal a transition metal, then what you are going to do is you are going to write the name, and you are going to use something called stock nomenclature. And don't worry, I'm going to teach you what stock nomenclature is at some point, okay, over the next couple of weeks. So name using stock nomenclature, and if possible, common name. Okay? So, for example, okay, iron 2, that's stock nomenclature, common name, ferrous, F-E-R-R-O-U-S, and like I said, we'll come back to this. What if the answer was no, right? Then it's a lot simpler, actually. What we then do is, if the answer is no, we just put the metal's whole name. So we put the metal's whole name. For example, something that's not a transition metal, right? So if we go over here, lithium, beryllium, sodium. Notice I didn't give you sodiumous or sodiumic or anything like that. It's just sodium. Why? Because the answer was no. Put the metal's whole name. Then we come back together on our yellow brick road for both ways, no matter what. And we ask ourselves this question. Is the anion, meaning the second part, the negatively charged portion, is the anion polyatomic? Now, eventually you're going to ask yourself, well, Mr. Groot, what do you mean by polyatomic? Well, you have a list of polyatomic, or ions. I gave you this list from the chemistry ions list, and I've highlighted in yellow a word right here, and it says commonly used polyatomic ions, okay? So polyatomic, if the answer is yes, it's located right here on your list, okay? It's located right there. And so if the answer is yes, it's pretty simple. That's the easiest way. So if the answer is yes, then what we do is just put the polyatomic's name. Hydroxide, carbonate, phosphate, okay? And so we just put the polyatomic's name. Polyatomic's name. It's a little more complicated if the answer is no. And here's why. What we have to do is we have to put the base of the ending, and we change the ending to IDE. So we do base plus IDE ending. And you've seen this before, okay? Like, let me give you an example, okay? So sodium, right? So it's not a transition metal, put the metal's whole name. Chloride. Well, if we looked for chloride on here, it's a monatomic ion. What does that mean? Mono meaning one, atomic meaning atom. So chlorine means there's only one type of atom, just chlorine atoms, right? Na and Cl. One type of atom, one type of atom. So sodium, it is not polyatomic. Instead of chlorine, we say chloride. Okay? So that's the left-hand side of our equation, or of our flow chart. Okay? So now we're going to deal with over here if the answer is no. And hopefully you're still with me. All right, so the first thing we're going to ask ourselves if the answer is no is we are going to ask ourselves this question. Is the first element, that's right, is the first element listed hydrogen? We're going to buy into something called the Arrhenius definition of acids for right now, okay? So we'll eventually learn about Q's and organic acids, but is the first element hydrogen, okay? And so, just like before, if the answer is yes, we go this direction. If the answer is no, we go in this direction. And so, if the answer is yes over here, what we do is we use something called acid naming rules. Okay? And for now, I'm going to give you those acid naming rules. And what we do is we look at the polyatomic that makes up the acid, okay? Or we look at the, actually, I didn't say polyatomic, it could be monatomic too. All right, we look at the anion of the acid, meaning the part after the hydrogen. That's a much better way to say it. And we do this. If the anion ends IDE, meaning something like chloride, right? Then what we do with that is we do this. We write the word hydro. We take the base of the acid's name. We write the word ic and the word acid. So that's how you get something like hydrochloric acid. Now, if the anion ends ite, I-T-E, if it ends ite, I-T-E, then what we end up with in this instance, okay, is we end up with the base of it. Notice there's not the word hydro at the beginning, just the base. So chlor, fluor, okay, phospho, all right? So we do base plus an O-U-S ending and the word acid, okay? So for example, if it was phosphite ion, PO3 at the end, right? It was H3PO3. The name of this would be phos. We put an OR into those to make them sound a little better, so it's phosphorus acid. Okay? And here's the last one. If the anion ends ate, A-T-E. So things like phosphate, chlorate, carbonate, that kind of thing. Then what we do is we take the base plus the word ic and the word acid, okay? So for the last one, it was phosphite, right? Well, in this case, we'll use phosphate, H3PO4. So in this case, it'd be phospha with the OR added on, phosphoric acid. And that's that. All right. So if the answer is no, and let's extend this a little bit further out. So if the answer is no, this is the very first time you're going to see me say this to you. Use the prefix system. Use the prefix system, okay? And so we're going to learn some things, okay? So what we do is this with the prefix system is we have a prefix at the very beginning. I shouldn't put it in parentheses. Okay. Actually, no, I won't. Prefix. I am going to note one thing. We never have a mono as the first thing. Prefix plus. Prefix plus. The whole name of the first element. Then we have a prefix, and we put this one no matter what, plus element, base, plus I. Okay, prefix, we never put a mono on the first one. Then we put the whole name of the first element. We then put a prefix, the element base plus I. Let me give you an example of one you know. Carbon dioxide. There's no prefix. Carbon is, so it's a C, one carbon. So we never put a mono on the first. We never say that. We don't say monocarbon. We just said carbon. So carbon, we don't say mono. The whole name of this is carbon. O2. 2 is dioxide. So let me give you those prefixes. For 1, the prefix is mono. For 2, the prefix is di. For 3, the prefix is tri. 4, tetra. And how I always remember that one is I remember a video game I love to play called Tetris. Okay? Number 5, penta. Number 6, hexa. Number 7, hepta. Number 8, octa. Number 9, nona. And number 10 with a C, deca. D-E-C-A. And those are our prefixes. And guys, this gives us our nomenclature flowchart, and I'd like you to have this written out. Now, I'm going to bring it towards the board so that you guys can see the whole thing. All right, so again, I'm just going to move. I'm going to move closer, and I'm going to move to my left. So if you've missed any portion of it, there's that. Okay. If my handwriting is challenging for you, you can pause the video right now, and you can see it right here. Okay? So, I would like you to fill in the entire flowchart so we can use it when we name and write chemical compounds.